time, we're going to be working on rational roots and polynomial. And if I had looked at this a little closer before I printed it off, I'm going to print it off this first page. So you can put an X through the first page and go straight to the back page. Okay, you're going to need your calculator. So grab that. If yours is 1 or 3, I have it. And it off right now. Fresh thing, that was 1. Which one is yours? 3? No. Okay, so we're going to look at this function, and we're going to graph it, and identify the roots from the graph. We're kind of guesstimating. So we're going to go to y equals, just like we did yesterday, graph 6x cubed plus 19x squared plus x minus 6 and zoom 6 is fine. Just set it to a standard window. Mine looks like this. You could have zoomed out a little bit if you wanted to. Is that what y'all got? So it kind of looks like that. You can kind of sketch it in there. So we're going to try to figure out, based on the picture, where we think the roots are, which just means where it crosses the x-axis. So it looks like it crosses here. What would you say that is? 3? Is it 3?
Negative 3, sorry.
Negative 3, yep. Okay, and then we have this one. Again, we're estimating.
Negative 0.75.
Okay. Negative, I'm going to just say 3/4. And what about the other one? 3/4. Another 3/4? Okay. Now we're just estimating, but those are very good estimates. Nothing wrong with those estimates. And we just got those from looking at our picture and seeing where it crossed the x-axis. So the problem is this x equals negative 3, like it says, is very clear. We can tell that that's negative 3, so that's awesome. But unfortunately, the other two are not whole numbers. So like you said, you were giving me decimals or fractions, and it's impossible to tell exactly what it is. So that's why we have this next theorem we're going to talk about, the rational root theorem. The rational root theorem lets us figure out what all the possible values are. And then we can look at those and see which ones match up or are close to those. Okay, so here's the rational root theorem. It is a list of all rational roots. Nope. I'm going to put numbers like they did. Rational numbers that are possible roots of a polynomial function and this can be formed by placing each integer factor of the constant term over each integer factor of the leading coefficient. Now last year you probably heard it, and you'll hear me refer to it as putting your P's over your Q's. You remember that? Does anybody remember that, kind of? Okay. You may not remember how to do it, but you at least remember that phrase, hearing that. You got to put your P's over your Q's. That's what we're doing. We're putting our P's over our Q's. And that'll give us all the possible rational roots. So I'm going to write that as possible rational roots. PRR. Possible rational roots. So first, on top, you would put the factors of the leading coefficient. So the factors of 6. That's the number that's in front of the variable with the highest exponent. Over the factors of the constant, the one that doesn't have a variable with it. So in this case, that is, oh, I did that backwards. Sorry, on top it should have been the factors of the constant. And on bottom it should have been the factors of the leading coefficient. Sorry, always saying that backwards. So our P's are the factors of the constant, and our Q's are the factors of our leading coefficient, putting our P's over our Q's. Now, it really doesn't matter if it's positive or negative, because when you factor it, you have to consider that that factor could be positive or negative in general. Because two negatives multiply to give us a positive, or a negative and a positive multiply to give us a negative. So it could be any positive or negative factor. So the factors of -6 are the same thing as factors of 6. Numbers that divide into 6 evenly. So we always start with 1. 1 will go into it. What's the next number?
2.
2 will go into it. And then 3. And then
6.
Yeah. And all of those are plus or minus. I just put the plus or minus right in the front. And on bottom, factors of +6, well, they're the same thing. 1, 2, 3, 6. So we're going to put each one of these numbers over each one of these individually. So, like, we're going to put plus or minus 1 over 1. So that's 1. plus or minus 1 over 2. Plus or minus 1 over 3. Plus or minus 1 over 6. And now we move to the next number, 2. Now, some of these will start repeating. So when they do, we don't have to list them again. Plus or minus 2 over 1, that's just 2. Plus or minus 2 over 2. Yeah, that's 1. We already got that, so we don't have to worry about it. Plus or minus 2 over 3. We don't have that one. Plus or minus 2 over 6. We've got that one, yeah. That's 1/3. All right, now we do 3. Plus or minus 3 over 1. That's just 3. Plus or minus 3 over 2. Don't have that. 3 over 3 we have, and 3 over 6 we have. 6 over 1 is 6. 6 over 2 is 3. We have that one. 6 over 3 is 2. We have that one. We're supposed to have that one. I just forgot to write it down. Sorry. And 6 over 6 is 1. Oh, I forgot to write that down. Maybe I thought we already got it. So let's see. 1, 2, 3, 4. So technically we have 18 because you can have the positive version of that or the negative version of that. So I know that -3 was a definite. And notice it's right there. The next one we said was -3/4. What do you think is closest to -3/4?
2/3.
Yeah, 2/3. So maybe instead of that one, do -2/3. Now, in this one too, let's look at them a little bit closer. I definitely see -2/3. Now look on the right. Get rid of that dot there. What do you think that is closest to?
1.5.
Yeah, it looks like 0.5.